Hi folks, this is Calc 3 Checkpoint Quiz 10. We're given a function of two variables and we're asked to show it's differentiable at a given point. So, how do we go about doing that? We can use a theorem. We have a theorem that says if fx and fy are continuous in an open disk containing x naught y naught, then f is differentiable at x naught y naught. Okay, so let's look at fx and fy. Before we start taking derivatives, let's rewrite this in a more derivative friendly format. We've got 3 times the quantity x squared y minus y squared to the 1/3 power. So I take the derivative with respect to x, fx, xy. So I've got 3 times the derivative of something to the 1/3 power is 1/3 times that something to the minus 2/3 power. And then chain rule kicks in. I'm taking the derivative with respect to x of what's inside. I do some simplification. The 3 and the 1/3 kill each other off. The derivative with respect to x of the inside is going to be 2xy. So I get 2xy times this quantity to the minus 2/3. And let's look what fy is. It starts off the same. 3 times 1/3 quantity x squared y minus y squared to the minus 2/3 times the derivative with respect to y of what's inside. The 3 and the 1/3 cancel out. The derivative of what's inside with respect to y is x squared minus 2y times this quantity. So looking at fx and fy, there's only one thing that could possibly go wrong. We've got this negative exponent here. And negative exponents, remember, means that whatever belongs to the negative exponent is going to be in the denominator. So in both of these things, the thing we have to worry about is having this thing in the denominator. So we have to figure out where x squared y minus y squared is equal to 0. We can factor the y out. And so now we get either y equals 0 or y equals x squared. So if I look on my xy plane at the forbidden zones, y equals 0, that's the x-axis. So this is going to be off limits, as well as the parabola y equals x squared. So that's also bad. But we're looking at the point 3, 1. So where is the point 3, 1? 3, 1 is right about there. Can you find an open disk around 3, 1 where everything's happy? Sure. There's lots of open disks that'll fit the bill. So we invoke that theorem. There's an open disk around the point 3, 1 on which fx and fy are both happy. And therefore we can conclude f is differentiable at 3, 1. And that'll do it for part A.